Said no student ever. So linear correlation. Now, best fitting line, that is, if you're doing it by hand, it's very subjective. Depending on which two ordered pairs you pick, which ones it gets closer to, right? Okay, so maybe we need a better way. But we do know this about this. This is y equals mx plus b, where the m is greater than 0. Meaning that the slope is what? Positive, right? We know that about that particular picture. Draw yourself another little small coordinate plane consisting of mostly first quadrant. Another little scatter plot action here. Some points. What do we think is trending with that particular? Yeah, they're decreasing as we go to the right. It looks fairly straight. Doesn't have an obvious pattern of a curve, right? So we can see from the scatter plot that this looks linear. So we could find a line of fit for that. Again, best fit is somewhat subjective for us to do it by hand. That seems to fit pretty good, but it may not be the best fitting line. But we do know this, that this is a slope-intercept equation, y equals mx plus b, where m is less than 0, right? We know that to be the case for that. But the idea here is that you can recognize a linear relationship based on a scatter plot, right? And then you can also recognize positive and negative slope. In the same way, you can recognize maybe this sort of thing happening. What do we know about that? It's constant. It seems to be all hovering around the same y value there, right? So it would, if we did a trend line on that, or a line of fit, it'd look like that. And we know that that's y equals mx plus b because it's a line, but we know that m, because it's constant, would be equal to 0. So horizontal lines have 0 slope. So a constant relationship there. In statistics, a lot of times we'll call that uniform. Just means it's around the same amount the whole time for the y value out of that. So that's also a possibility. And then we have the different case where we could have, maybe there's no relationship, maybe there is a relationship, but maybe it's not linear. And how do you know that? Well, you can see some sort of pattern happening there. We see that those dots, they don't follow a straight line, but there is some sort of pattern out of that, and we know that would be considered non-linear. And depending on context of the particular problem this data set came from, and ability to find a line or an equation of fit, what kind of nonlinear equation that could be. It could be quadratic. We'll see that in the next section. We'll talk about quadratic things. It could be, honestly, it could be cubic. It could be a sine curve or a cosine curve, something like that. There is a ton, or are a ton of nonlinear functions that could happen. And depending on the context of the problem, which one we would shoot for and try to get for an equation. Our focus in 4.2 is this linear relationship. The human eye is really good at finding straight lines. Most of our buildings, all these blocks, you got straight lines all over the place because you can eyeball that pretty well. Finding the exact curve is a little more difficult, and a little more difficult mathematically as well. So what we want to do is take some data and then find a line of fit And then we're going to use some technology to find the line of best fit. Okay, so line of fit and line of best fit. So let's get a couple of sets of data. So let's get example A, and I'm just going to use a T-chart here, get some X and Y values. 3, 0, 5, 2, 7, 3, 9, 6, 11, 9, and then 13, 11. Okay, so we want to, we got all these ordered pairs here, and we want to determine what kind of relationship they have, and if it's a linear relationship, we're going to find that equation. We're going to do a line of fit, which means do it by hand. We're going to do a line of best fit, which means use the calculator to help us find that the perfect fitting line, the one that's closest to, on average, to all of them. Okay. So the first thing we would want to do is do a scatter plot, and we could do that by hand, and that's wonderful. We do that a lot in Algebra 1. We do scatter plots by hand. Sometimes you'll do those by hand. When it's a small set like this, that's probably easy to do. But we have the miracle of I think this is a biblical miracle, the graphing calculator. That's a joke. It's not a biblical miracle. It's a wonderful, wonderful tool, but we're going to do a scatter plot with it so that we can just get a look at what these look like. Does it make a straight line, or does it trend toward that? If it does, we're going to find the equation that goes with it. So we're going to use calculator to do that. So the way that you can put ordered pairs into your calculator and get it to plot them is to hit the stat button, which is right here, right beside the arrow buttons. Okay, and we want to edit. Hit edit. Well, first, everybody's may not be set the same way first. I want to make sure everybody's is set the same way. So hit the stat button, and then everybody this first time hit the setup editor, and it should put that on your regular calculator screen, and then hit enter. That will just reset everybody's list in case somebody's is not set the same. So that gets us all the same. All right, now hit stats, and then we're going to select edit. I've got a bunch of stuff in here from statistics last fall, so I'm gonna delete those things. Yours, especially if you rented one, may have some stuff in it too. Okay. To delete things that are in a list, what you want to do is press the up arrow until that list name is highlighted. Okay. So list 1, I want to get rid of all this stuff because I got X values to put in there. So I'm going to hit clear and enter, and it'll empty that list. I'm going to do that with list 2. I'm going to press over and then up until the name of the list is highlighted, and hit clear and enter, and it'll empty the list. Okay, you'll need to do that. Make it easier on you as you go through practice to be able to clear out and put in the next set. So I'm going to clear out these others. Not that I need the L3 and L4, but just because it bothers me. All right. In L1, we want to put our X values. So we're going to use those X values from that table, 3, 5, 7, 9, 11, 13. So a little easy to remember. 3, 5. So you type the number, hit enter, and it goes to the next spot. 3, 5, 7, enter, 9, enter, 11, enter, 13, enter. Bless you. All right. And then I press the right arrow key and get into list 2, and I'll put the Y value that goes with it. Make sure you're pairing it with the correct X value. So 0, 2, bless you, 3, 6, 9, and 11. Okay. Does anybody not have the list in yet? Just want to make sure I want to run off and leave you this first one here. So we've got those in list 1 and list 2. We're going to treat that as the X list and the Y list. All right. The next thing to do is get your calculator to do a scatter plot. In order to do that, you want to hit second and Y equals. And that gets you to this stat plots menu. All right. I'm just going to pick stat plot 1. press enter. And then if it's not turned on, I want to turn it on. So I just highlight on, hit enter. And then on the type, you got several different things your calculator will do. The first choice is the scatter plot choice. The next one is a line graph. Hey.
We got one sausage rest on this chicken.
Okay, it's a race for the sausage. Yeah. Scatter plot's first option. This is a line graph that just connects the dots. And then this is a histogram. So if you need to make a histogram, you take stats, we'll use that a lot. And then these are box and whisker plots. And then this is a step graph out of that. The main thing is make sure you're on scatter plot. Your X list was list 1. That's where we put it in. Your Y list is list 2. If for some reason yours does not have that in there, or something got pressed, it was in your bag and buttons got mashed or something, and somehow it changed that. To get list 1 back in that, you hit second and then the number 1. If you look above number 1 in blue, it's L1. So that's how you select a list for your calculator to use. And if you needed to change that to list 2, you just second number 2. Now, the mark that you choose doesn't really matter. I use the box here because I can see it pretty easily. The plus sign's pretty easy to see. This last dot's pretty difficult. You know, it's just one little pixel that it puts a dot in. I use the box. It doesn't matter which one of those you use. Okay, I use the box because it's pretty easy to see and kind of recognize the pattern out of that. So once you've done that, you've got it turned on. You've got the type selected to be scatter plot. You've got list 1 is X, list 2 is Y. You got your mark selected. If you've got the color one, pick what color you want those boxes to be. It doesn't matter. So I'm going to hit graph. My window is crazy. It's got some other stuff going on in it, and I don't see any of my dots like I should, right? So what I want to do is I want to clear out my equation that I had in there from yesterday, and then I want to hit zoom, and then I'm going to use zoom stat, which is option number 9. Zoom stat will zoom in your window so that you can see just the scatter plot that you've made. So I'm going to hit zoom stat. And there we have our scatter plot. Isn't that pretty? You'll get faster at it. It doesn't take that long once you're used to it. So does that look like a linear trend? Yeah. Is it perfectly straight? No. Should it be? No. But it's pretty straight. It's almost a line. Okay. So from that, you can tell, okay, this looks linear. I want to find the equation of that. So we're going to find a line of fit. So if you're trying to find a line of fit, the idea would be look at it, kind of eyeball what you think would be a good fitting line and pick 2 of the ordered pairs to use. Okay. So if I don't have a long ruler in here, this will work. If I look at that and I think, okay, if I put a line like that, maybe if I connect this one and this one, it's pretty close to all of them. Or if I connect this one and the last one, it gets a little closer to those. You know, just eyeball it and pick 2. Now, when I ask you on a quiz to find the equation of the line of fit, and it's not with the calculator, I'm going to tell you which 2 to pick. Okay, so that we're all finding the same line. And I don't have to do 23 different keys out of that. So I'm going to pick 2 ordered pairs. Let's pick that. Which one was that? On the graph there. Second one and the last one. Just because I think those 2, that ordered pairs would get me a line that fits pretty good. Okay. So in order to write the equation of the line, so we're going to find the line of fit. If I'm going to use those 2 ordered pairs, what do I have to find first? Slope. So 11 minus 2 over 13 minus 5. 9 over 8. Okay. So f of x is equal to 9 over 8 x plus b. And then what do I do next to find the y-intercepts? Plug in one of those ordered pairs for x and y and get it. So I'm going to use 5, 2. Pretty easy. All it's needs today. So 2 is equal to 9 over 8. 5 plus b. Work that out. 45 over 8 plus b. 2 is 16 over 8. Subtract. And that would be, if you took 15 away, it'd be 30. 16 away would be 29. So negative 29 over 8. Got it. What's that close to? Like decimal wise? 3.6. It actually is exactly 3.6 out of that. So that's important to know, because when we find our line of best fit, we're going to get decimals, because the way the calculator does the calculation, and then it's not going to give us usually fractions out of that. So we've got an equation for a line of fit that is f of x is equal to 9 over 8 x minus 29 over 8. If you wanted to write that, as a decimal, 9 divided by 8, 1.125 x minus 3.6. Okay, so there's our line of fit. Let's get the calculator to crank out a line of best fit. Okay, so to crank out a line of best fit, we're going to use your calculator. You're going to hit stat, and then we want this calculator to calculate something. So we're going to go over to the calculate menu there in the middle, and we're going to do a linear regression. Okay, the calculator does a lot of things. If we wanted to do one variable stats, we could get the average, the mean, the quartiles of any list that we've got. Two variable stats does that for two different lists at the same time. Median to median comparison there with two different lists. Linear regression, LINREG. Your calculator also does quadratic regression, cubic regression. Quartic regression means fourth power. And then it does a different linear regression depending on what context you're in. This gets you the same thing, you just swaps where the slope's at. Only difference. Then there's a natural log regression. It does several more. We're doing linear regression in section 4 too, so we want to pick option 4. And then it's kind of the same way you did the scatter plot. Make sure your X list is L1. Make sure your Y list is L2. Frequency list should be blank. You don't have a frequency list. A frequency list would be like list 3 would tell you that this ordered pair showed up 5 times, that ordered pair showed up once, another ordered pair showed up a different number of times out of that. So we don't have that for our information. The store regression equation, you can actually get it to save that thing. We're going to see it, and we're just going to write it down. Storing the regression equation is not something that you really have to do here. So we're just going down here to calculate and hit enter. Boom. 1.1285, all those decimal places. And we're going to round to, let's go 2 decimal places. Be a good one. So the slope is what? 1.13. The Y-intercept, negative 3.86. So f of x is equal 1.13x minus 3.86. What your calculator is doing is measuring the distance between the line and all of the ordered pairs. It's the least squares method of doing that. So if you want to look that up, you can. But their calculator is doing all those calculations in the background. Did we do pretty good with our estimate here? That's pretty close. 1.125 is pretty doggone close to 1.13, right? it actually would round to the same slope. So we did an okay job. Yes, sir. Check your ordered pairs. You did. Three zero. 1, 2, 7, 3, 9, 6, 11, 9, 11. Let's see here. You got the previous list. It should be blank. That's what it is. All right, good. All right. So, line of best fit, that is the best fitting line. And if you wanted to graph that onto your scatter plot, you can. Y equals 1.13x minus 3.86. Hit graph. And there's that line going through that scatter plot. So we can see that it does fit fairly well on there. Okay. Nice. Okay. One other thing that could be handy with your calculator, if you hit the mode button for me. So the mode button right there beside second. And then look for stat diagnostics. Look for that button. And let's turn those on. I'll show you another thing that your calculator will kind of help you decide if it fits well or not. So stat diagnostics. Is anybody having trouble finding that? Stat diagnostics. Turn that on. And then let's hit the stat button and let's run that linear regression again. And I want to show you what your calculator will add to the information there. So 4, and then everything should already be set. Hit calculate again. And notice that, we've got our slope or y-intercept the same as it was, but it adds this information here. Those are your correlation coefficients. R is your correlation coefficient. When R is closer to 1, or actually R squared, the closer R squared gets to 1, the better the fit is. R, as the correlation coefficient, if it's positive and close to 1, that means it fits really well. The closer R gets to 0, the less of a positive relationship we have. R, plain R, can be negative. If it's negative, when we have a negative slope, right? R squared really tells you how well it just fits. Anything R squared that's close to positive 1 fits well. Anything R squared closer to 0, it doesn't fit real well. So that kind of can help you decide, hey, did this fit really good or not? That idea with that. So that having those stat diagnostics are kind of handy when you're trying to decide did it fit pretty good or not. And that's only going to happen on anytime you do any sort of regression. Having those stat diagnostic on, you're going to get those two values back, and it can tell you whether it fits pretty good or not. In a math class, anything above 0.9 is a really good fit. In the real world, anything above 0.5 is a good fit. That's kind of how it works. If you're in a statistics class, or if you're a statistician, you're doing things. Most of the time, real world data doesn't fit the R squared of 0.98. That just, if it does, then you probably have too much detail in your equation, and it probably is not going to be very predictive of overall across the board kind of stuff. Let's do one more, and then we'll get out of here. Get a table, X values, Y values, -2, -1, 0, 1, 2, 7, 6, 3, 2, 0. Let's find a line of fit, and then a line of best fit. I'll go ahead and tell you it is a linear relationship. Use those two to get the line of fit. That way we all find the same line. Y'all should have the Y-intercept already. will the line of fit. Most of you have gotten started. Just going through the calculator stuff again with you here. To hit stat to get and edit to get to your lists. And then we want to clear out a list. So I'm going to press up and then clear, enter, and that will empty a list. -2, -1, 0, 1. Here to list 2, clear, enter, 7, 6, 3, 2, 0. Why did I not have to do any work on the Y-Intercept? And I picked that order pair that has 0, 3 in it. That saves me a little time. Did the line of best fit, did it fit pretty good? As good as the last one? Not quite as good. 0.97 for the R squared as opposed to 0.98. Not much difference there, but that is a little bit less, but he's still considered really, really close fit. Did we get pretty close with our line of fit? Our Y-intercepts off quite a bit, but our slope's pretty close. So we got, they should be similar. When you find a line of fit and a line of best fit, they should be fairly similar out of that. And you could graph both of those on your scatter plot, if you wanted to determine that. So if I hit, the good thing about the graphing calculator is once you turn the scatter plot on for plot 1, it stays on until you turn it off. So if I hit graph, I'm gonna get rid of that equation that I did earlier. If I hit graph, notice I don't see much. I see 1 point there, but I got a different set of ordered pairs. So what do I need to do to get this to resize? Zoom 9, and now I can see, hey, there's my negative relationship with those ordered pairs that I put in. So once you turn that scatter plot on, all you got to do then is hit graph and then zoom 9, and it'll show you the new one for your list 1 and 2. As long as you're using the same 2 lists, you don't have to go back through turning it on and stuff. Once the kicker here is once you go past doing scatter plots and that sort of thing, and you need to turn that scatter plot off so that it doesn't mess up graphing other equations. So if you're on ACT, if you're taking that on February the 9th or something, you might need, make sure before you go in that you turn your stat plot off, because it's going to mess you up if you go to graph something else. Usually it'll cause a problem. All right. So that is section 4.2 in a nutshell. Page 291, 5 through 25. Not many but I mean, it's a lot of finding equations and all that sort of stuff. Easy stuff though.